All right. Good morning, friends. It is Wednesday. Um, so we are going to be doing Lab 4.1b, modeling the water cycle. I was going to do this yesterday, but I didn't have what I needed here at the house, so I had to go grocery shopping and get a couple things. So I ended up just switching it around. So as you guys know, I posted questions yesterday instead. I'll be sure to post those answers today after I make this post. So let's take a look at this thing. So in order to model a water cycle today, you're going to need a few things. So you need a 2-liter bottle prepared, and it says C diagram below. And I'll show you that in just a second. You'll need a lump of clay or dirt. I like went outside and grabbed just a clump of dirt, and I kind of squished it together into like a dirt ball. Plastic cup of 10 ounces of water. So just like a regular glass, pretty much. You'll need warm water from your faucet, and you'll need some ice cubes today. So this one's not too bad. All right. So first, you have these 3 questions you need to answer in your notebook. So look at the diagram of the water cycle in packet 2, then answer the questions in your notebook. Sorry, I was snapping at my kitty. So this is the water cycle picture. It's in packet 2. Okay. If you don't have packet 2 anymore, you can look at this one. Give you a good picture of it here. And you can find like any water cycle or cycle picture online if you would like, and it will serve the same purpose. So you can pause it here to look at this. All right. So number 1. So how does water move from the atmosphere to Earth's surface? So atmosphere is up here, Earth's surface is here. How does the water get from here to there? So you'll see you got a list of definitions here. And if you haven't already guessed it, I mean, you can literally see the word precipitation by the rain falling here. Okay? Number 2, how does water move from the Earth's surface to the atmosphere? So how does it go from here to there? So if you haven't already guessed it, I mean, we know that water, when it reaches a certain temperature, evaporates and becomes a gas form that goes up into the atmosphere. Okay? Number 3, how does water move across under the Earth's surface? So we have good old runoff. So once the water falls down, becomes runoff and groundwater, and it kind of goes back into the main water source. Okay. Moving on to prediction. So read over the directions for the rest of the investigation. How do you think you will model processes of the water cycle? Write a prediction in your notebook. So how do you think the little model we're going to make is going to show parts of the water cycle? All right. I suggest that you answer this before you finish watching this video so that you have a real prediction. Otherwise, your prediction won't be accurate. You'll just write whatever we did. And I really want you to think about it. That's what a prediction is. If you're ever doing an experiment, it's important for you to think of the outcome before you actually do it. Okay. Moving on to model. So at the bottom of the bottle, you want to put your dirt. Okay. So I went outside, got a handful of dirt, crumped it into a dirt ball. And you can use clay. If you have clay around the house, it'll be easier to use because clay is a little easier to form. But you get some wet clay dirt, works just as good. All right. Be sure that the clay covers no more than half of the bottom of the bottle, but that the landform you create will stick out of the water that you will add in step 2. Okay. So step 2. Use the cup you got, the 10 ounces of very warm water, and then pour the water into the bottle. So get your cup of hot water from the tap and pour it into the bottle. Make sure you don't cover all of your landform that you made with your clay or your dirt. Okay. Make sure that the cap is tight on the bottle, and then turn that bottle upside down and position it in the bottom of the bottle as shown below. So they're talking about this picture here. Okay. I mean, here's mine right here. So as you can see, I cut the top of my bottle off and then I flipped it upside down. I filled this up with hot water. You may not believe that there's dirt in here, but there was. The water level rose and ended up covering my land. So we'll talk about that in just a minute, but I cut this out and I flipped it upside down, okay, so that you put the ice cubes in this almost like a little bowl. Be careful when you're putting the ice cubes in this. Make sure this doesn't fall in. Okay, whoop, it'll fall right down on this. So kind of hold that in place and carefully make sure, because the ice will make this heavy. The ice will make this heavy. Okay. All right, flipping this back over. Make sure the cap is tight. Turn that bottle, the top of the upside down. Okay, and then you're going to put a bunch of ice cubes in the top. All right. Flip this over. So this is what it should look like, basically. All right, so I've left mine for like an hour. You're going to observe the inside of your model and you're going to draw and label what you see in your notebook. Okay, so you're going to draw this, right? You're going to draw your version of it, though. And then you're going to draw and label what you see, okay? And you're going to observe your model several times over the next hour, labeling your drawing on any changes that you observe, okay? So I'm going to talk about some things that I observed. All right. So over the last hour, the first thing, I mean, it looked like just there's some water in the bottom, there's some ice cubes in the top, and then there was a little bit of landform showing. Here's what's happened. Okay. First and foremost, my landform is gone. The reason why this is because water from the top here started to fall down and kind of raise the water level of this. All right. You'll notice there's a lot of evaporation happening inside of the bottle from the hot water and it being gaseous and going up. You'll notice that there's no evaporation where the ice is. The ice is cold enough that it's actually becoming condensation in that area. Okay, so the hot water or the gaseous water is going up. It's hitting the ice, cooling and condensing and becoming a liquid form, and then falling down back into what would be your landmass area. Okay, so foggy here, not foggy there. And obviously, I mean, you're noticing that the ice is slowly melting at room temperature. Okay, so that's what I would label for that. So if I were drawing this, I would have a bunch of condensation here on this part of the bottle. I'd have evaporation and it'd be really foggy here on the sides. I'd have my water level kind of increasing a little bit. So that's what I would draw for that. All right, let's answer some conclusion questions. So what did the clay and warm water you added to the bottle represent in your model? So what does the hot water down here and your dirt mean? Okay, so I would say that the clay or dirt is like Earth's surface, like the real Earth. And then the water that's in there, the warm water, is water that's been warmed by the sun. The reason why we made this warm water is so we wouldn't have to heat it up. We could already start to see the process of evaporation. So the sun heats the water up, and that's why it evaporates up into the sky. Okay. Next, what does the ice represent in your model? Well, the ice up here, that's the atmosphere. Think of it as like the clouds. Okay, it's much warmer down here than it is up there. Okay, and think of that as, so when the water, that's what causes the gaseous water that evaporates to condense, and condensation occurs, and this is what turns it into rain. That's what makes it fall. That's what makes it fall back down. Okay, to our Earth's surface. All right. Next, what process in the water cycle does your model represent? Well, we have evaporation, we have condensation, and we even have precipitation. So we have water being heated, evaporation, you can see it on the sides. You see all that fog. Goes up into our atmosphere, cools, and condenses. You can see all of this condensed water as it cooled and stuck to the side of this. Okay, and if you look real close, you see that drip at the very bottom of that cap? That's precipitation. That's it condensing enough that it's gaining enough weight and falling back toward the earth. Neat. Okay. So how do you think your results would change if you used cold water instead of warm water? Explain. Well, if it was cold water down here, it would take longer for it to evaporate. Right? Because you'd have to heat it up either under the sun or at room temperature, and there's no guarantee that it would gain enough temperature to actually start to evaporate. So if you use cold water, it would take longer. Okay, because there's just less heat. Okay, so less heat takes longer for this to do its thing to get up there. So we sped the process up by putting hot water down here. All right. Number 5. How do you think your results would change if you did not add ice to the top of the bottle? Explain. If we didn't have ice up here, it would take longer and a lot less of this would condense. The reason why this is condensing so thick up here is because this is almost like flash cooling the evaporation, the evaporated gas here. So it's like it comes up and it's like, boom, instantly freezes it back down to a condensing temperature. And that's why we see such a massive accumulation or collection of, come on phone, of water droplets here on the top here. Man, that looks cool. Or should I say looks cold? Ha ha ha. Mr. Nannon's jokes. Okay. So yeah, there'd be less condensation at the top of the bottle without the ice. It wouldn't be doing what it's doing. All right. And the last one. So what are a couple questions you guys have about the water cycle? These are your own questions. What I thought was pretty neat is students were coming into Google Meets, and the questions that they were writing down for these assignments, they're actually coming in and asking me. And that's great. That's why I want you guys to write these questions, because I encourage you to ask them. All right. So I will be in Google Meets today from 1 to 2 o'clock. And if you have some questions that you wrote down about the water cycle and you'd like me to answer them, please. I love talking about this kind of stuff. If you guys have any questions on how to make this or any ideas of what to use if you're struggling to find a bottle. I just got a 2-liter soda bottle and I cut it. Let me know. Okay, that's why I'm here. All right. So that's all I have for today. Hope your guys' lab goes well. And I will talk to you soon. Have a great day.